Thermodynamics. Refrigerators and refrigeration cycle. Marine refrigerators and refrigeration cycle. The refrigeration plants on merchant vessels play a vital part in carrying refrigerated cargo and provisions for the crew on board. The main purpose of ship's refrigeration plant is to avoid any damage to the cargo or perishable material so that it is transported in good and healthy condition. Refrigeration prevents growth of microorganisms, oxidation, fermentation and drying out of cargo, etc. Vapor compression cycle. The basic components of any refrigeration system working on the vapor compression cycle are the compressor, condenser, expansion valve, evaporator, and the refrigerant fluid, which is alternatively vaporized and liquefied during the refrigeration cycle. The temperature at which a fluid boils or condenses is known as the saturation temperature, and it varies with pressure. Choice of refrigerant. Mechanical refrigeration makes possible the control of the pressure and therefore, the temperature at which a refrigerant boils, within the limits of critical pressure and temperature. The closed circuit ensures repeated use of the same refrigerant with little or no loss to atmosphere. There are certain factors which determine a refrigerant's desirability for a particular duty, and the one selected should possess as many as possible of the following characteristics: moderate condensing pressure, high critical temperature, low specific heat of the liquid, non-corrosive, chemically stable. The current concern with depletion of the ozone layer has resulted in a new requirement that refrigerants should be environmentally friendly, so the most preferable refrigerants are R134A, tetrafluoroethene CF3CH2F. R407C, mixture of hydrofluorocarbons, zeotropic blend of difluoromethane, R32, pentafluoroethane, R125, and 1,1,1,2 R134A, R404A blended hydrofluorocarbon HFC, refrigerant comprised of R125, R134A, and R143A. Working of refrigeration cycle. The refrigeration cycle starts and ends with the compressor. The refrigerant flows into the compressor where it is compressed and pressurized. At this point, the refrigerant is a hot gas. The refrigerant is then pushed to the condenser, which turns the vapor into liquid and absorbs some of the heat. The refrigerant then proceeds to the expansion valve where it expands, losing pressure and heat. The refrigerant coming out of the expansion valve is cold and slow due to the loss of pressure. It enters the evaporator in a liquid state where the exchange of heat takes place, thus cooling the load inside the refrigerator. As the gas cools down the load, it absorbs the heat, which turns it into a gas. The gas is then pushed back into the compressor where it can start the cycle again.